The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay. Problem 19 states a 0.1 kilogram ice cube, no friction, therefore, slides along a horizontal surface with a velocity of 6 meters per second and hits a stationary ice cube of mass 0.2 kilograms. They stick together, then slide up a 30-degree slope to a height measured vertically of h. Find h. So, definitely want to draw the situation. So, we start out with an ice cube over here, 0.1 kilograms, hits another ice cube, 0.2 kilograms. Then they stick together, and they slide up and they reach a height h. Okay, so now you see this problem, and hopefully you start thinking, well, we got something moving, it has a certain velocity, it's, in this case 6 meters per second. It goes up to a certain height, you should think energy, and that's absolutely correct. However, if there's a collision, energy cannot work through basically from before to after that collision. So oftentimes what you'll do is you have a problem such as this, where you have a collision, where you use momentum. Momentum is pretty much always your key concept for collisions, and then you can use energy after the collision to see what's going on. So our basic approach to this problem is we're going to use momentum to figure out how fast these two blocks are moving right after the collision. Then that velocity is going to tell us how high up the ramp it goes. So to figure out this velocity right here, we use our momentum equation where we say basically our initial momentum is always going to be equal to our final momentum. Now in an inelastic situation, that's going to be m1 v1i plus m2 v2i is going to be equal to m1 plus m2 times our one final velocity because they're stuck together. Now, our mass 1 was given to us as 0.1, our velocity was 6. Mass 2 was given to us as 0.2. Velocity of 0 means this term drops out. 0.2 times 0 is, of course, 0. Now, mass over here is 0.1 plus 0.2, and that's going to be multiplied by whatever our velocity is. Now, final, of course, is a relative term. It refers to the final velocity in relation to the momentum. This is not going to be the final velocity up here. It's going to be the velocity right here. So 0.1 times 6 gives us 0.6. This gives us 0.3. So our final velocity is just going to be equal to 2 meters per second, 0.6 over 0.3. Now we know the velocity right here is going to be 2. And we know the mass of this guy is 0.3 kilograms. Now, like I said before, anytime you're going from a velocity to a height, generally energy is going to be your best bet. So I'm going to say this is my datum where potential energy is equal to 0, the level it starts off with. So that means it has no potential energy right here, but it's moving, so it has kinetic energy. So we have K initial is going to be, don't get too confused, some people use P for potential energy, PE, depends on what you're doing, just make sure you know what the variable means that you're using. So our initial kinetic energy right here turns into our final potential energy. We know our formula for kinetic energy is 1/2 mv squared. We know our formula for potential energy is mgh. Now, 1/2 mv squared, the velocity it starts out with after the collision, we already calculated, so that's going to be 2. Now, in your problems, I highly recommend you always use 9.8. In this particular problem, the professor that wrote it used 10 for gravity, which is a common situation. If you always use 9.8, you'll be fine. You won't get an exact answer that's on the sheet, but you'll get one that's really, really close, and you won't ever have two different answers that are too close to tell which way you round it. So Don't worry about it, you'll get basically the exact same answer I'm going to get if you use my 0.8s for gravity. So, we can cancel our masses. And we can say that basically 4 over 2 is going to be equal to 10h. 4 over 2 becomes 2 over 1, and our height is going to be equal to 0.2, 2 over 10 meters. Now this is going to be our answer. They told you that there's a 30-degree incline here. They did that to try to trick you. The incline doesn't matter. It could be 30 degrees, it could be 60 degrees. It could have a curve to it, or it goes like this. It doesn't matter. Potential energy, if there's no friction or no other forces going on, just tells you how high up it's going to go. So if it's 30 degrees, it's going to go way out here and up to 0.2 meters. If it's 80 degrees, it's not going to go nearly as far, but it's still only going to reach 0.2 meters. So when you're dealing with potential energy, just remember our angles don't matter. This would have only mattered if we had a situation with friction or something where we had to actually determine the length of this. So 30 degrees was actually extraneous information. You did not need to know that for this answer. And that is how you solve this problem. H is equal to 0.2 meters.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.